So in this video, we're going back to the basics. Let's talk about what components are needed for a computer and how they all interact with each other. Let's get started. Hey everyone, Jason here with Dad Talks Tech, a channel dedicated to PC building, component reviews and overviews, but also tutorials and educational videos, just like this one. So consider subscribing if you're new here. Now, a little while back, I did a series on how to build your own computer in a step-by-step tutorial, and I originally was going to include this video in the series, but I thought that the information in here was a little too 101 for that guide, so I decided to keep it out on its own. And today I'm going to talk about all of the components needed in a computer and how they all work together. There are a lot of pieces that you could throw into a computer, from your CPU, GPU, storage, case fans, and even some fun RGB lighting stuff. But what I'm going to focus on in this video are the main components that are in every PC build: the motherboard, processor, graphics card, power supply, memory, and storage. And of course the case itself. This tutorial will be pretty basic, as I want to make this channel accessible to every experience level who is interested in building a PC. Basically, I'm going to go over this like I'm talking to my 11-year-old who understands some tech but has never seen the inside of a computer. If you're already above this level, feel free to drop your advice in the comments below. So now that we're ready to go, let's talk about the primary pieces of every computer: the CPU, motherboard, graphics card, RAM, power supply, and internal storage. The first thing that you have to decide on is what CPU platform you want to work with. The central processing unit, otherwise known as the CPU, or just processor, is basically the brains of the computer. Right now, there are two main platforms to choose from for most gaming and productivity computers: AMD and Intel. Both have their pros and cons, and I don't necessarily want to get into that in this video, but it is important that you choose, as it will help when choosing which motherboard to lean towards. When choosing a CPU, you will see stats like core counts and clock speeds. To put it really simplistically, you can think of the number of cores and threads as the amount of processes that the CPU can do at once. You can think of this sort of like how many lanes on a highway. Clock speeds are how fast those processes can take place. Think of it as the speed limit of each individual lane. So ideally, you'd want a processor with as many cores and highest speeds that fit into your budget. Again, based on your use case. If you only intend to play video games on your computer, then they don't tend to use a lot of different cores, so you would want to prioritize speed over core count. But if you want the computer to do more streaming, video editing, or photo editing, having those extra lanes, those extra cores, can be very beneficial to those types of applications. So now that you've decided which processor you want, it's time to choose the motherboard. The motherboard is sort of like the nervous system in the body. It sends signals to and from all the other different components attached to the motherboard. Motherboards can get a little confusing. For processors, you basically only have two choices in manufacturers, but with motherboards, you have way more and several different options for both AMD and Intel processors from each manufacturer. The very first thing you need to worry about is if the socket on the motherboard matches the socket of your CPU. For AMD, this is fairly easy. If you are using one of the Ryzen CPU architectures, which is the current and past couple generations, then you are looking for an AM4 socket. Intel is a little more complicated, as the generations have changed the socket size a bit, but it will most likely be an LGA 1151 or an LGA 1200, depending on if it's an 8000, 9000, or 10000 series chip. So just double check that they are both the same before you purchase. On top of the socket size, you have to make sure that the board size fits your case. You'll see eATX, ATX, MATX, and ITX. Again, you don't necessarily need to know what each of these means. You just need to make sure that the motherboard you choose will fit into the case that you choose. Another thing to consider would be the number of USB ports given, network connectivity, and whether you want Wi-Fi built in or not. As I mentioned, there are quite a few options, and I plan on doing a video talking about the differences more in depth in the future. All right, on to the graphics card. The graphics card's job is to deliver images from your computer to your monitor. If you are using your computer primarily for gaming, then this probably would be the component in which you spend the lion's share of your budget. There is a large price difference in this area as well, from a couple $100 all the way up to a couple thousand. If you're not building a computer to play games or do photo or video editing, and you just need something to surf the web and maybe watch Netflix or Disney Plus, then you can get away without a dedicated GPU, as long as the CPU that you purchased has integrated graphics, which most Intel CPUs do, and a few few AMD CPUs do. Make sure to research if your processor has integrated graphics, if this is something that you want to take advantage of. The major thing you want to look for in a graphics card are 1, the video memory, also called VRAM, measured in gigabits, and clock speed, measured in megahertz. Like your computer as a whole, the more video RAM and the higher clock speeds, the more processes your GPU can handle. Some of the higher end models will also tell its game clock or boost clock, which is a profile that you can set within the software to overclock the graphics card to perform better than its base configuration. Number 2, does it physically fit into your case? Graphics cards can come in a multitude of sizes and generally speaking have 2 or 3 fans to cool them off, which can both make them quite long and thick. This Asus TUF Gaming 5700 XT-OC model, for instance, is 10.6 inches long and 2.1 inches thick, which means it would really be tight in some ATX cases and takes up nearly 3 PCI slots in your case. So make sure that you have room in your particular case for your graphics card. Lastly, you want to make sure it has proper interfaces for your monitor or monitors. This card, for instance, has 3 display ports and an HDMI port on it. And my monitor has a display port on it as well, so I'm all set. The next component I want to talk about is the RAM. Random access memory, or RAM, is essentially short-term memory. It temporarily stores all of the applications that are currently running on your computer. Things like the browser window, Windows services, or the game that you are playing. It's extremely fast. However, it's volatile, meaning that once your power is shut off, it forgets everything. This is the reason that we need a more permanent storage environment like SSDs and hard drives that we'll speak on in a moment. There are a few things to look out for when choosing RAM. Make sure that the generation matches what your motherboard supports. The current generation is DDR4. However, DDR5 will be coming in the very near future, and there are still a few motherboards out there that support DDR3. So after you've made sure that the generation you have matches, you'll want to consider how much RAM you'll need. RAM sticks come in different capacities, whether that be 4, 8, 16, or even 32 gig. You want to make sure that you have enough to run the programs that you want. Currently, if you're just gaming, 160 gigabytes is about the standard that I would start at. If you're doing a lot of video or photo editing, I'd look at bumping that up a bit, maybe to 32 or 64. Also, current motherboards give better performance if you have RAM sticks in multiples of 2, meaning you will get better performance out of 2 8 gig sticks versus 1 16 gigabit stick. Along with capacity, RAM also has a clock speed measured in megahertz. You'll usually see this listed as DDR4 3000 or DDR4 3600, where the DDR4 is the generation and the number after the dash is the megahertz. Generally speaking, the faster the megahertz, the better. To make things even more complicated, RAM also has a cast latency that you will see as a CL number, for instance CL16 or CL18. This can get a little complicated, but it's basically the amount of clock cycles it takes to complete its task, and so the smaller the number, the better. I would say that this number has the smallest impact on your gaming performance though, so in general, if you were choosing between a RAM module with a speed of 3200 and a CL of 14, or a module with 3600 and a CL of 18 that were the same price, I would choose this 3600 with a CL of 18. Now, as I mentioned before, RAM is sort of the short-term memory storage while that particular program is running, so we need a more permanent storage in order to hold our operating system and all of the games and files. There are basically 3 different storage devices that can meet this requirement. First, you've got hard drives. Hard drives come in 3.5 or 2.5 form factor and have spinning platters, much like a vinyl record that stores the data. Some pros. It can store a lot of data. You can find some that would hold up to 16 or even 18 terabytes now. They are relatively inexpensive compared to SSDs and NVMEs of the same size. Great for large amounts of data that isn't accessed all the time. The cons are that it's kind of slow. They don't generally have the same read speeds, read or write speeds as an SSD or an NVMe. They're also more prone to failure due to the spinning disks within it. They're also less robust, meaning that if you drop them, they can break quite easily. And they also take up a good amount of space. They're, like I said, 2.5 inch or 3.5 inch drives, and generally need some form of drive bay within your case. Solid state drives, or SSDs, do not have any spinning parts and hold data on a chip. These generally come in a 2.5 inch form factor. Some of the pros, they are faster than hard drives, but they're still cheaper than NVMEs, and they tend to last longer than hard drives as well. The cons are that they're more expensive than hard drives, and they're still slower than NVMe's. Which brings us to a non-volatile memory express, or NVMe SSDs. NVMe SSDs plug directly into the motherboard through an M.2 port. These will have the fastest speeds by far of any of the storage devices, but also cost the most. These have come way down in price recently. It would be a great place to store your OS and games that you play quite often to decrease load times. Now we come to the power supplies, and I think I might create a separate video on this, but for now the biggest thing to worry about is if it has enough wattage to power the rest of your components. There are a few sites out there that can help you determine how much wattage your components will use, but give yourself a little headroom on that as well. For instance, if all the parts you're using are around 400 watts, I like to look for something in the 600 watt range. And lastly, we come to the case. There are so many cases out there on the market, ranging from $30 to $40 to a few hundred. The most important thing to think about is, does it fit in the motherboard you choose, and does it fit in the space that I want to put it in? Also, I'd pay a bit of attention to what people are saying about the airflow of the case. Heat can kill a CPU, and if a case doesn't allow for proper airflow, it can greatly reduce the lifespan of your PC. So that was a bit of a long one, but thanks for showing up. I hope it gives you a better understanding of what the components are that go into a PC and kind of how they all work together. Like I mentioned in a few of those, I plan on doing a more thorough breakdown of the motherboards and power supply and those kind of things. And you'll be looking forward to that in the future. To learn a little bit more about becoming a patron for the channel, to be sure to check out my Patreon link in the description. If you like the video, give me a thumbs up, subscribe to the channel if you're new here, and hit that alarm bell so you can be kept up to date on all my future content. As always, comments and questions can be left below for suggestions. Thanks for hanging out, and we'll see you next time on Dad Talks Tech.